Welcome to Unit 5, Lesson 7. And this lesson is going to focus on some applications. And there's actually loads and loads and loads of applications for logarithmic and exponential functions. I've mentioned some in class like population control. The Richter scale is a logarithmic scale. The pH scale, half-life of, in chemistry or physics, the half-life of a radioactive element. There's just lots of things in the real world that are modeled by exponential and logarithmic functions. But our benchmarks for this class focus on financial applications and specifically interest. Okay, so that is the application that we're going to focus on today, but it's certainly not the only application that there is. So how interest works. Now, I am not a finance person. I don't, never studied finance, so I'm not really super savvy with my own money, but I have a basic idea of how money works. So just bear with me here. So how interest works. So you put money in the bank or some kind of an investment account. Maybe you have a CD of some sort and you put the money in the bank. Now, that money that you put in is called the principal, okay? Usually represented by the letter P. So that is our first vocab word. So it's the starting amount. So I'll put that here. Like it is the starting amount of money, or the money at like the beginning. Now, the bank invests or lends this money out, and they basically pay you for letting them use your money. Okay, this is the super, super simple version of it. But you might go to the bank to put money in, but other people go to the bank to take out a loan. Say they want to buy a house or they want to buy a car. And so they need money loaned to them. Now, they will charge that person interest. So if you've had to take out a loan, someone in your family has had to take out a loan, you pay it back with interest. And so essentially what the bank does is they take your money, they lend it out, and they get more money back because the person that they lent it to is going to pay it back with interest. And then you get some of that interest, okay? And the money they pay you on that is called interest, and it is expressed as a percent. Okay, it's often represented by the letter R, and it's expressed as a percent. So you might say, well, this account pays 2% interest. And you might have heard people talk about interest rates. Okay, we have a lot of things going on with the economy, and people will talk about interest rates, and that can mean both the interest that you might pay on the loan, paying it back, or the interest or the interest that you're getting on your account, and they tend to rise and fall together. So something called simple interest is calculated by finding the percent of the principal and then adding it back in. So this is a simple example. You invest $2,000 and it pays you 4% interest. How much interest will you earn, and what is your new balance? Now, I want you to notice that there are actually two questions there. Okay, we have how much interest will you earn? That's the first question. And then we also have what is your new balance? And when you're doing a multiple choice question, for example, you could be asked either of those questions. And I can almost guarantee you that one of the distractor choices will be the answer to the other question. So you do need to read the question carefully. Am I being asked for the interest, or am I being asked for the new balance? New balance is just how much money you now have in your account. Okay, so let's go with this. Now I'm going to do a little bit of a percent review here. So percents are something that you should learn in like late elementary / middle school, maybe all the way up through 8th grade. I remember teaching percents in 8th grade, and it's really good to know that. But we'll do a little bit of a breakdown of what a percent is. So the word percent, if you look at it, you can kind of break it into two. Percent. Now, CENT is one of those roots. We've been doing the MANTA morphology this year, and so we've been seeing the teachers kind of compete with each other about like the root words and stuff. So cent is one of the root words, and you've probably heard this in, say, century, or like cents as in like how many cents we have in a dollar, or maybe like centipede. Okay. and so forth. If you look at that, what they all have in common is the number 100. How many years are in a century? 100. How many cents are in a dollar? 100. Now, I don't actually know if a centipede has exactly 100 legs or if it's just a euphemism for a lot of legs, because after so many legs, I mean, do we really want to count? But I think you get the idea. So literally the word percent means per 100, or if you're more comfortable, you could say out of 100. And the reason we like percent so much is because they give us this like base value, so we have an idea of how much we're talking about. So for instance, if you scored 13 out of 20 on a test, you might be wondering, well, what percent is that? And so you could do that any number of different ways. You could do 13 divided by 20 and then multiply by 100. You could set up a proportion and say 13 out of 100 or out of 20 is what out of 100. And then you would get, I believe that is 65. Okay. So you would, yeah, like 65. So that would be 65%. And so X would be 65. And so it's 65 out of 100 or 65%. So that's a little bit of background on what a percent is. And I hope that does make some sense to you. Now, the quickest way to convert into a percent is usually to, remember, I'm not using the pen that I use in class, so I cannot do the flip over thing. So I'm going to go ahead and erase this, make some room for some additional work there. Okay, it is to divide it out. So to do 13 divided by 20 and then multiply. Now, here's the deal. When you're dealing with interest rate problems, you always need your interest rate as a decimal. And so we're going to have to do just a little bit of moving around. So my strategy, what I'm going to recommend that you do and even require you to do this, is to list what you know. So we know that the principal here is $2,000, and we know that the interest rate is 4%. Now we do need that 4% as a decimal, and the way you do that is you move the decimal point 2 places to the left, and that has to do with that out of 100, you're actually dividing it by 100, and that will move the decimal point over. Okay, so that's literally what's happening there. And so we want to know what is 4% of 100, or no, not 100, it's 2,000. Whoops, what is 4% of 2,000? Okay, and when I taught middle school, I used to do this to take that and translate it into an equation. So what is what we want to know? So we'll call that X. Is your equal sign. Okay, so what is, and then 4% is 0.04, and the word of means times, and there's your 2,000. So if you want to pause the video and kind of write that down, that's a bit of a useful thing to know how to do. So like the what is the X, the is the equal sign, the of is the times, and then you would grab your calculator, and I do have a calculator here. And we'll do, and I got to clear out some stuff. So 0.04 times 2,000, and that is $80. Okay, in this case, that's $80. And so that's how much interest you would make. Okay, so you're making 4% of 2,000. Now, the other question there is, what is your new balance? Well, the old balance was 2,000, and now you're going to add 80 to that. And so your new balance is 2,080. And again, both of those questions are questions that are likely to be asked. So what is the interest and what is your new balance? And one of them, you would have to add that in. Now, here's how interest works and why like very rich people can live off their interest. The next time the bank collects that interest, so I'm going to erase what we got going on over here. They are going to calculate the 4% off a bigger number. And so the next time you're going to do what is 4% of 2080. Okay. And so 4% of 2080 is going to be a slightly bigger number. That is going to be $83.20. Okay. And then that gets added in. And basically what happens is this is called compounding your interest. So like every time you calculate the interest, it gets added back in. So now you don't have $2,080. Now you have $2,163.20, I think. Just did that on the fly. And so every single time it's compounded, you're getting like that percentage of a bigger number. And that's how you can make money, by investing your money. That's why people will shop around for a good interest rate. And basically it's a win-win-win. So like the bank is a business, so the bank makes some money off of it, but you make money off of it as the investor, and the person borrowing the money also wins because they got like a loan that they needed. Now that's what's called simple interest. Now there are two other kinds of interest that we're interested in. As you add more money into your account, your principal increases, and the next time you earn interest, it will be higher, even if the percent is the same. Typically, interest is compounded at regular intervals or possibly continuously. Both of those formulas are exponential. So what we just did on that last slide, where we would like calculate it again and again and again, you don't really want to have to do that all the times that it might be compounded over, say, the course of 15 years. Okay. And so what we would do is we'd look for a pattern and develop an equation for it. So here's the equation for compounded interest. Now I'm going to try to translate this for you. A is like the ending amount. Okay. It's the amount at the end of the time period. Okay. And they have that listed as total amount. P is the principal, okay? That's your starting amount. R is your interest rate, okay? Oops. Interest rate as a decimal, okay? As a decimal. And N is how many times it's applied usually per year, okay? Is how often, we'll say per year for the sake of simplicity, it is compounded. And T is the number of years. And now, if you look at that, it does say it's how many times it's compounded per time or per period, time period, and it doesn't say it's necessarily a year, but like for simplicity, we'll say like it's a year, but somebody could throw something at you where it's different. Okay. And pretty much you would read the word problem. You would identify like, this is the total amount, this is the principal, this is my interest rate. You'd plug the numbers in, and in theory, you'll have one variable that you don't know. So it might be the interest rate or the time or the compounding periods or the amount, the total amount, or the principal, like you don't really know. But it would be like one of those. And then you would use your algebra skills to figure out what that is. Now, on the right, we have what's called continuously compounded interest. And you think, whoa, if it's compounded continuously, I'm going to get really rich really fast, except you don't. Now, I am going to rewrite this. I snagged this off of the interwebs, but it's not my favorite form of it. I like using the A to keep it consistent with the formula on the other side. And then you just have P e to the RT, and you'll notice that that is your natural exponential. Okay, that's the base. And when I taught this in class, I did say this number shows up, this E number, just it shows up, this 2.7181, blah, blah, blah. Okay, and everything else is the same. So you've got the amount, the principal, the interest rate, and the time period. So most problems of this type will involve knowing all but one of the numbers, and then you needing to find the missing number. And it's not necessarily the same number every time. So while it's good to have some examples to look at, you don't want to fall into the trap of thinking every single one of these problems is, I can just mimic all the steps. You do have to take each problem individually. So let's take a look at this. So problem number one, you invest $2,000 at 4% interest, compounded 4 times per year. How much money will you have after 5 years? So when I was in school, I had a teacher he was a really, really good teacher, and he drilled into me this method or strategy for setting up your problems. Okay. And it was just a way to structure the work so that we could get started with it. And I've always wanted my students to do it too. It served me really, really well. Okay. It really helped me develop a good problem solving technique. So we've got several things that we know. Like we've got all these numbers, okay? And you can go through and circle them, like what are the things we know. And sometimes like a given is not going to be given to you as a number, okay? So and that can happen, so you just be aware of that. And now I'm going to create a list. So I've got the $2,000. What is the $2,000? Well, it says you invest $2,000. So that sounds like it is the starting amount. At 4% interest, so that is my R value. And don't forget, you want that as a decimal. It's compounded 4 times per year. This is that N value. Okay, it's how many times per year it's compounded. Now, this is where you could see other words. So the word quarterly would mean it is compounded every quarter or 4 times per year. Semi-annually, I think, is twice a year. But that might be once every 2 years. I'm not going to give you that one. There's biannually and semi-annually. Go ahead and look them up. A lot of times it'll be yearly or monthly. If it's a monthly, it'll be 12 times per year. How much money will you have after 5 years? Well, that 5 is my T value. And now when you look at that list and you've got to decide, well, what formula do I want? Hopefully you'll notice that you have a certain collection of variables and things that you know in this one formula that'll work. And so this would be the compound interest formula. And so you're going to write down the formula. So list your givens. Okay, I'll point to them here. List your givens. So just create a list. Write down the formula that you intend to use. Don't put any of the numbers in it. Just write down the formula that you intend to use. Then go ahead and put in the numbers that you know. So we've got a 2,000. We have a 0.04 divided by 4. And this is 4 times 5. Some of this you might be able to do like in your head. So like, we'll go ahead and I can do that because I know 4 times 5 is 20. Now I'm going to could I figure that out? Maybe. Now, what I recommend like from here is that you guys Desmos it. Okay. You're just going to go straight into Desmos and get your answer. Okay, that's what I would do. Now, I don't have Desmos up on this screen, so I am kind of stuck having to do this the long way. What would be awesome is if I didn't put decimal points where I didn't want them. Okay, so doing it out the long way, this is 1.01 to the 20th. That is a period. And then I'm going to take that and raise it to the 20th power. And then I'm just going to go, if you guys can see, I'm just doing it on a calculator here. But I don't want to write down that's kind of a awful decimal. Well, I guess I can write it down. I'm going to have to round it though. So this is about 1.22. We'll leave it at that. And then I'm going to take that and multiply it by 2,000. And I get $2,440.38. And we're going to round to nearest penny. Okay, so there we go. And so that's how much money we would have left in our bank account. Now, there are other variations on this. So you might be asked to find the principal, or you might be asked to find the time, or like you might be asked what interest rate should you be looking for if this is the money that you want. But that strategy is a really, really, really solid strategy for you to use. Generate a list of what you know, write down the formula you intend to use, plug in your numbers, and then from there, hopefully you can jump from there to Desmos, but you might need to do some algebra. Okay, it depends on what you're being asked for. All right, it's problem number 2. How much money do you need to invest at 2.5% interest compounded continuously to have $10,000 by the end of 5 years? Right? And so I'm going through there and noting the things that I'm given. So I am told the interest rate is 2.5%. Now, when you go to change that to a decimal, it does change exactly the same way that the others do. You move the decimal point 2 places to the left. Just notice that because the decimal, like there was a 0.5, that you now have 3 decimal places after because it was 2.5. Now it's $10,000 by the end. So that means that's that final amount. Okay. So that's the final amount, not the initial amount. And again, just read it carefully. The 5 years is the T. And then the last piece of information that I have there is that it's compounded continuously. So that is the second formula. That is PERT. Think of like PERT, like the PERT test. Seniors need that qualifying PERT score. So write down what you know, then write down the formula that you intend to use, and then go and plug in. So A is 10,000. We don't know P, okay? But we do know that E is going to be to the 0.025 times 5. Okay, and this time we are looking for P because it said how much do you need to invest or what do you need to start with. So you want to, I don't know, do something with the business and you need $10,000 at the end of 5 years. This is the interest rate. How much money do you need to lock into that account? So I'm going to go ahead and do the multiplication on that exponent. So that is 0.025 times 5. All right. So that is e to the 0.125. And then that is just a number, e to the 0.125. So I'm going to figure out what that number is. So I need to find an e on this calculator. There it is, e to the 0.125. And that number is 1.133. And we'll kind of leave it at that. And then this is multiplication. So to get the P by itself, we will divide by 1.133. There's my P. So we want $10,000 divided by 1.133. Whoops. Got to do that again. Divided by 1.133. There we go. That's much better. And it looks like I need to invest $8,826.13. Okay, so if I take $8,826.13, we put it in this account that makes 2.5% interest. In 5 years, we will have earned enough money to bring it up to $10,000. All right, so this is one for you to try. So go ahead, pause the video. If you're doing this from home, pause the video, give it your best shot. Okay, write down all the givens, choose a formula, okay, and then see what you can do with it. If you want to unpause it, try it. I'm going to give you a hint, but pause it first and then unpause it if you need the hint. Okay. The hint I'm going to give you is that if you want the money to double and you're starting with $5,000, then you would want to invest it long enough to double it, which would be $10,000. So if you need that little hint, go ahead, pause the video again and see if you can take it from there. Okay, so let's see how you did. So you have $5,000 to invest. So that's your starting amount. You got $5,000. Burning a hole in your pocket. And you have chosen an option that is compounded continuously. That's like your tip off to which formula at an interest rate of 3%. So hopefully you managed to write down the interest rate there. That is a period. How long do you need to invest the money in order for it to double? So our final amount, we want to be 10,000. So that was the hint that I gave you. Now, compounded continuously means that we will be using this formula, except that is an exponent. And I've got $10,000. That's what I want to end with. What I began with was 5,000, and I have an interest rate of 0.03. And the thing that I'm looking for is t. So this is an exponential equation. Now, for some of you, you might like it better if you just switch the order around here, okay? And you just put the 10,000 on the right instead of the left. That is entirely up to you, okay? Just whether or not you want to do that. So we need to get the exponential by itself. So going into our like rules for solving exponentials, and this is usually a good lesson. So a couple class periods ago, this was fine. 5,000 divided by 5,000. Sorry, I'm inconsistent with what I put the leading zero in there. That equals 2. And now we're going to change it to a log. So this would be log base e of 2 is equal to 0.03t. But we know log base e is really just natural log 2. And we got to go grab our calculator because none of us know what that is unless we just did it off the top of our head. That is 0.693. And to get the t by itself, we will divide both sides by 0.03. And divided by 0.03. And I get about 23.1 years. So that money is going to take about 23 years, a little bit more than 23 years to double. Now, an interesting fun fact about this is that I don't even need to tell you the $5,000. Okay, so I could completely, I could completely wipe that out. Okay. And just start with you have chosen an option that has continuously compounded interest at a interest rate, blah, blah, blah. How long do you need in order for this to double? Okay. So you might be surprised, like, wait a minute, how would I do that then? Okay. So let's kind of, so now we're doing it and we don't have the 10,000 and we don't have the 5,000. All right. Okay, so now how does that come out in the wash? So let's say I don't know how much I'm investing. Let's call it, we can call it P, okay, because it's principal, but we could call it X. So we don't know. I haven't told you. Now we want it to double. Well, what is double X? That would be 2X. So when we come over here, do we go to substitute it in? The amount at the end is going to be 2X. And the principal, oh, wait a minute. I did not put that in the right spot. Show me. Okay. So we have 2X, and then the principal was X. And now instead of dividing both sides by, then we like changed it around. So we had X times this. I just like changed the order. Okay. Now instead of dividing by like the 5,000, now we need to get this by itself. We're just going to call this X, right? X divided by X is 1. X divided by x is 1, and you end up in the same place. And you could also try that with putting in different numbers. Like you say, instead of 5,000, what if it were 500? What if it were, but the truth is that when you get to that step, 2x, 2 times anything divided by the anything is always going to be equal to 2. So you'll always have a 2 there. Another thing people could do there is say triple instead, in which case you'd end up with a 3, or quadruple and you'd have a 4. So now I don't think I'll do that to you, but like I could. So heads up. All right, so your classwork / homework. Now, your strategy, I want to like re-emphasize, like this is your strategy. So we have no like IDKs, nothing blank. Okay. Make a list of all the numbers you know. So we call that list you're given. So you might say T equals, A equals, N equals, whatever the list is. You're going to make a list and read through and try to put the numbers in the right spot. Choose a formula and write the formula down with no numbers in it. Just like, which of these formulas am I going to pick? Am I going to pick the compound interest, or am I going to pick the continuously compounded one? Okay. Then plug the numbers from your list into the formula that you chose. And make sure that I can see that. I can see this is the formula and this is where you put the numbers in. If you put the numbers in the wrong spot, then I'll be able to see that you did that and we can work from there. And then solve for the variable that you have left over, whatever that is, okay? And it could be the principal, it could be the amount, it could be the time, it could be the interest rate, like it could be whatever. So your problems are: find the final amount in an account that starts with $500 and accrues 2% interest compounded quarterly over 10 years. And Stan has $1,000 and wants to have $3,000. In other words, he wants his money to triple. If he can invest it in an account where interest is compounded continuously for 5 years, what interest rate does he need? What does he need to shop around for? So there you go. And as always, you guys know how to find me with any questions that you might have.